right, guys, are there any questions on the assignments thus far? Because we've only had assignments for 7.1 and 7.3.1. We didn't cover 7.2 and we're not going to. So we're good with 7.1 and 7.3.1 so far? Well, 7.3.1 was covering multiplication. So 7.3.2 is going to be covering division. Now, what we're doing today is, for 7.3.2's notes, is not going to take 2 days. We'll be able to cover this in 1 day. Because the difference between 7.3.1 and 7.3.2 is very, very small. Because whenever we divide two fractions, we don't actually divide. We don't do division like long division or kind of a synthetic division type process. Because whenever we divide two fractions, we, well, change it from division to multiplication and flip the second. So really, besides that first step, this is going to be exactly the same as multiplying two rational expressions. Because whenever we divide, we change it from division to multiplication and flip the second. And after we do that, it's going to be the exact same as multiplying two rational expressions together. Any questions on this here? Now, there is going to be one big difference with our restrictions. And if we look at this here and we said x is equal to -2, well, would this be an issue? Because, I mean, for both of these denominators, 7, -2 plus 1, here we'd have 2 times -2 minus 3 over -2 plus 2. Spin the page. Well, in the denominator of the first rational expression, -2 plus 1 is -1. In the second one, well, 2 times -2 is -4. Minus 3 would give us -7. Well, neither one of the denominators there are 0, correct? In the numerator of the second, -2 plus 2 is 0, yes? So what happened to the second rational expression? This whole thing would be 0, yes? So what would I have? 7 over -1 divided by 0. Well, we can't divide by 0, correct? So with our restrictions for dividing rational expressions, get the highlighter out, it's not just looking at these two denominators. We also have to look at the numerator of the second expression. So the whole second expression cannot be 0 or the two denominators because we're dividing, not multiplying. And that's the only real difference with the restrictions. All right, let's go on and look at the first one. Now, when we look at any of these here, the first thing I would do for dividing two rational expressions is not to factor. The first thing I would do is change it from division to multiplication, as I already did, and flip the second. Bless you. Bless you. So the second one is going to have x squared minus 11x plus 30 on top, and x squared minus 6x on bottom. Now, it is possible that you can do this all in one step, change it from division to multiplication, flip the second one, and factor everything all at once. But I would not advise it because, again, if you're doing more than one thing, doing so many things at once, it is very easy to flip a sign or lose track of a number. Or not even flip the second one at all. So it's easier to just go on and do the change it from division to multiplication and flip it, first write that down and then factor second. So if we look at these here factoring, there is one of them that's not going to change at all. Which one would that be? 7x. Because it's only one term, we can't factor or do any type of factoring with it. Out of the other three, which ones would be easier to factor? Or look like they would be easier to factor first? Because what can we do with the 2x minus 10? It has a greatest common factor of 2, yes? We can factor that out. And if I factor it out, 2 factored out of 2x would just leave us with x minus 5. So anything where I'm just taking a greatest common factor or probably a difference of perfect squares are the ones I would work with first. If we look at the second expression, well, we have x squared minus 11x plus 30 and x squared minus 6x. Which one do you guys want to work with first? Yeah, the x squared minus 6x, because what can we do? We can factor an x out. Because both terms do have a greatest common factor of x. And if we factor it out, an x factored out of x squared would give us x minus 6. And that leaves us with the x squared minus 11x plus 30. Now, again, if we want something to reduce on top and bottom, do we have anything that reduces so far? We do have one thing, because we have 7x, and do we have an x by itself on bottom? Well, yes. If we're going to have anything else reduce, inside these parentheses here, I'm going to need what? An x minus 5 or an x minus 6, yes? And this is why I simplify what's kind of easier first, because it does give me a roadmap or a hint at what these parentheses could be, yes? So let's go on and factor it. Since the 30 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Well, the factors of x squared are, now let's look at the factors of 30. Well, 1 and 30, 2 and 15, 3 and 10, but I think the bigger one is 5 and 6. Well, hey, if it is 5 and 6, I now have an x minus 5 on top and bottom. I also have an x minus 6 on top and bottom, yes? So if that works out, I do have two things in common on top and bottom that will cancel. And if we do check this, x times negative 6 would be negative 6x. Negative 5 times x would be negative 5x, which gives us a negative 11x, which is the middle term that we wanted. So factoring the quote-unquote easier ones, because our difference of perfect squares are greatest common factors, and getting those simplified first does help us see what the other factors could be. And it does help us out. Now what that leaves us with is multiplying these together. We would have 7x times x minus 5 times x minus 6 on top. On bottom, we'll move the x times 2 up front times x minus 5 times x minus 6. Any of the greatest common factors in any of these sets of parentheses, I always move them up front. Because the x is a greatest common factor, so we'd multiply with any others, so 2. So we get 2 times x on bottom. Now we do need to cancel out anything that's in common on top and bottom to simplify it. Well, we would simplify the x minus 5. Also the x minus 6. Anything else? bx and x, which leaves us with 7 over 2. We'll look at the restrictions for this one here and one other so that y'all can see them and kind of know what we would be looking for. And whenever I look for restrictions, I don't look here. I don't look when we multiplied everything together, because not everything in the numerator and denominator will be a restriction. The only ones that are going to be a restriction are the two denominators in the numerator of the second. So the two denominators in the numerator of the second. Or we can say the whole second expression and the denominator of the first. And as we look at this here, well, we do have an x minus 5 and an x minus 5. We do have it in two spots. So we only need to list that restriction once. What value of x is going to make x minus 5 0? 5, because 5 minus 5 is 0. Now we also have x minus 6 and then x minus 6. Well, that would be 6, because 6 minus 6 is 0. So we can't have a value of x as 5 or 6. But we do have one more. And that would just be our x. What value of x is going to make x 0? 0. And I mean, we could have set each one of these equal to 0. So x minus 5 is equal to 0. Add 5 to both sides, telling me x is equal to 5. We could have done the same thing with x minus 6 is equal to 0. Add 6 to both sides, telling us x is 6. So those two don't work. In the last one, I can set x equal to 0, and that's it. So really, if we have a variable as a greatest common factor, or a variable by itself, like 7x, or x times x minus 6, well, we know one of the zeros has to be, one of the restrictions has to be 0. We're skipping this one. Let's see here. Oh. We can do this one here. We'll skip the next one because the next one's going to end up being 4/5. So let's look at this one here first, and then we'll move on to some more that are a little more interesting. So when we look at any of these here, well, the first thing we can do is what? Change it to and flip it. So at the division, we're really changing it from division to multiplication and flipping the second. So the first we'd have 11x over 3x minus 9. In the second one, we're going to have x squared minus 8x plus 15 over x squared minus 5x. So now we want to factor. So again, kind of as I pointed out in the last one, if we can find some that are factored a little bit easier, it might help us with the ones that are a little bit more intricate. Well, the 11x is just going to remain 11x. We can't really do anything with it. Which one do we want to factor next? And how would we factor 3x minus 9? Yes. 3x and 9 do have a greatest common factor of 3 that we can pull out. If I factor 3 out of 3x, I'm left with x minus 3. So that one having a greatest common factor of 3 is not too bad. Which one do we want to try next? X squared minus 5x, because it does have a greatest common factor of x. And if I factor it out of both terms, I'm left with x minus 5. Now that leaves us with our x squared minus 8x plus 15. Now looking at this here, since the 15 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Well, the factors of x squared are x and x. And what factors of 15 would we want to use? 3 and 5, because 3 times 5 is 15. And we do have an x minus 3 and x minus 5 on bottom, so that does help us in simplifying things out. Now at this point here, we can multiply the numerators together and the denominators together, which would give us 11x times x minus 3 times x minus 5 on top. And on bottom here, we'd have 3x times x minus 3 times x minus 5. Well, x minus 3 and x minus 3 cancel. X minus 5 and x minus 5 cancel, and our x's cancel, leaving us with 11 over 3. Not every problem will work that way, but these two here have been set up so that they do work out that way. Any questions on this here? This problem here is set up in the exact same manner, so it ends up actually being 4/5. I don't find that very interesting, so we're going to move on and look at this one here. I gave you that there, so if you wanted to go back and re-look at it and work it out, you can. But all the variables, other variables would cancel out. Now this one here, just like with the last ones, we're going to change it from division to multiplication first. And flip the second. So the first one is still going to be 4a squared minus 1 over a squared minus 4. Now the second one's going to become a minus 2 over 2a minus 1. Once we have that written down, we can move on to the multiplication. Or not multiplication, our factoring. Now looking at these four spots, these four expressions inside the rational expressions, there's two that will factor and two that are not going to change. Which two won't change? A minus 2 and 2a minus 1. Because if we look at either one of those, the degree is 1. The exponent connected with the variable is 1. So we're not going to be able to factor it that way. Also, there's not a greatest common factor between either two terms, so they're simplified. There's nothing we can do with them. But the other two we can. Which one do we want to factor first? 4a squared minus 1. Since there are only two terms and they're being subtracted, it'd be really nice if it is a difference of perfect squares. Well, 1 is a perfect square, because 1 times 1 would give us 1. Now the question is, 4a squared, is it a perfect square? Well, yes, because 2 times 2 would give us 4, and a times a would give us a squared. So 4a squared minus 1 is a difference of perfect squares, which would mean that we'd have 2a minus 1 and 2a plus 1. And now we can look at the denominator, a squared minus 4. Well, a squared minus 4 is a difference of perfect squares. A minus 2 times a plus 2, or we could have had it done the other way around, a plus 2 times a minus 2. Because the order of how we place those two really doesn't matter as long as we have both. Well, everything factored so we can multiply it together. So we can say 2a minus 1 times 2a plus 1 times a minus 2 over a minus 2 times a plus 2 times 2a minus 1. So if we look at this here, there are only two things in common on top and bottom, which are our a minus 2 and our 2a minus 1, which leaves us with 2a plus 1 over a plus 2. This one here's the last one. We'll really look in close, in depth, kind of at the restrictions for this here. And again, when we're looking at the restrictions, we're mainly focused on the denominator of the first and the entire rational expression of the second, the entire rational expression of what we're dividing by. And so when we look at this here, so we can look at the a minus 2, and well, this here, the a minus 2. Since it does appear twice, well, that's only going to need it once. And it would be 2. Because we can set it up as a minus 2 equals 0 to see what value of a is going to make it equal 0, which would be 2. That way that was not in the video and accidentally blow someone's eardrums out. And the other one we would look at is a plus 2, which would be negative 2. Because we would subtract 2 from both sides, telling us a is negative 2. So if it's 2 or negative 2, it would cause a division of 0. Now the last one that's probably not as easily seen is the 2a minus 1, which would be 2a minus 1 is equal to 0. So we would add 1 to both sides, telling us 2a is equal to 1. Then divide by 2, telling us a is equal to 1/2. So the restrictions for this here are 2, negative 2, and 1/2. All right. So these three here are the restrictions. Now, the problem like here, the textbook would not list negative 2 as a restriction because, well, stop moving like that. The a plus 2, where we got that restriction from, is still in the denominator, so it's not going to list it because it's still written. It's only going to list the ones that simplified out. I would still list all the restrictions because I think it's good to have them listed and not make that kind of exception. Any other questions on this here? All right. Let's look at another one here. Well, the first thing we can do is change it from division to multiplication. And we still have y squared minus 9 over y squared. And over here, we're going to have y plus 2 over y to the 5th plus 3 y to the 4th. Now looking at this here, again, there's two parts of it that will not factor. Those are already in simplest forms. And those would be our y squared and the y plus 2. Because the y squared does have a degree greater than 1, but it's only one term. Y plus 2 is a degree 1, but does not have a greatest common factor, so we can't do anything with it. Which one do we want to factor next? The y squared minus 9. And this one here is a difference of perfect squares. So it would factor 2, y plus 3, and y minus 3. And now we need to look at the other one, y to the 5th plus 3y to the 4th. Now the first thing we would look for is a greatest common factor, and is there one? Y to the 4th, and we can factor y to the 4th out of both terms, and then see if we can factor it from there. Well, if I factor a y to the 4th out of y to the 5th, I'm left with y plus 3. Well, after factoring out the y to the 4th, everything that's left inside the parentheses, 1 is a degree 1, and there's no greatest common factor, so it's already simplified. I have a feeling it's picking up some other touch. I have no idea what it's picking up. There we go. So if we multiply what's on top, we have y plus 3 times y minus 3 times y plus 2. In the denominator, we'd have y squared times y to the 4th, which would be y to the 6th times y plus 3. Now let's see what simplifies on top and bottom. So we would have the and y plus 3. What else? Is there anything else? No. So on top we would have our y minus 3 times y plus 2 over y to the 6. Really, the only way that we can have another greatest common factor is if in the numerators we had a greatest common factor of y we could have pulled out. So that there would be the answer. Any other questions on any of these here? We feel kind of comfortable with doing these quotients, these divisions. Yes? All right. Well, I want to look at one more. As we do have those using cubics, sum and difference of perfect cubes. But realistically, that's no different than what we did on Friday. This one here is not any more complicated than what we've been doing, but I do want to go over it just so we can see it. Now, our first step is not going to change, because we're still going to change it from division to multiplication. On top of the first, we'll have 6x squared plus x minus 15 over 4x squared. And the numerator for the second one would be 1 over 3x squared plus 5x. Because again, whenever we have a term without a denominator, it is understood to be 1. So when we flipped it, That 1 went from the denominator to the numerator. And now everything is going to be the exact same as what we've been doing. So the first one, well, we'll still have the 4x squared. And the second, we'll still have the 1. Now the question comes down to, do we want to factor 6x squared plus x minus 15 first, or the 3x squared plus 5x? I would go with the 3x squared plus 5x first. Because, well, we only do have 2 terms, so is there a greatest common factor between them? Well, yes, it does have a greatest common factor of x, which would tell us that we have 3x plus 5 left after we pull that x out. Because if I factor x out of 3x squared, we're left with 3x. And when I factor an x out of 5x, I'm left with 5. So that one there is not too bad to factor. Now the 6x squared plus x minus 15, it would be good to make sure there's not a greatest common factor between these 3 terms, which there is not. So we can look at factoring them. Now the signs, since 15 is negative, our signs are, one's going to be positive and one's going to be negative. Now the factors for 6x squared, well, our x squared is going to be x and x. That's the only way we can have x squared in the first term. 3 and 2, where do we want to put the 3? With the plus, and we want the 2 with the negative. So why did you want to put the 3x with the plus? Because we want it to be like this down here, yes? Again, it kind of gives us a roadmap, exactly. And the factors of 15 are 5 and 3. So I can put the 5 with the plus and 3 with the negative. Because if I have it set up exactly this way, I have a 3x plus 5 on top and bottom. And if we wanted to make sure, because 3x times negative 3 would be negative 9x. Positive 5 times positive 2x is going to be plus 10x, which would give us a positive x, the middle term that we wanted. Now when we multiply all this together, now the numerator is just going to be 3x plus 5 times 2x minus 3. We don't have to include the 1 because multiplication of 1 does not change anything. The denominator, 4. X squared times x would be x cubed times 3x plus 5. And if we simplify out what's in common on top and bottom, our 3x plus 5 and our 3x plus 5, it will leave us with 2x minus 3 over 4x cubed. And that's as simplified as it gets. Because the only way we could really have simplified the 2 and 4 is if the 2x minus 3 had a greatest common factor of 2. But that's it. Any other questions on any of this here? If not, that is all we are doing